Hi there. Good morning, everyone. Welcome to our webinar. I hope you can all hear me. My name is Jenny Peterson. I am the Manager of Marketing and Communications at RLE, and I'm going to help moderate the webinar this morning. So we're all glad you're here. Thank you for joining us this morning. Let's kick off our discussion about improving airflow efficiencies. Our presenters this morning are Tim Hirschenhofer. He's the Senior VP of Operations at RLE. He has more than 15 years of data center efficiency experience. A lot of that focuses on cooling, airflow, and data center monitoring. So he is an excellent resource to talk to us this morning about containment. Our next presenter is James Schneider. He's a mechanical engineer at RLE Technologies. He actually started with us as an intern from Colorado State University. We were so grateful to have him, so impressed with the work he did. We offered him a job, and we're lucky enough to have him come on full-time and work for us. James designed our new RFM panel. He also designed a line of grommets that we're launching this month. And if you have ordered a custom logo airflow panel from us, James custom designs each one of those panels. Tom Metzinger is our third presenter. He's our Vice President of Sales at RLE. He's new to the company. We are very glad to have him. He has got more than 25 years of sales and sales management experience, and he's a great addition to our team at RLE. This morning, we are going to be talking about the benefits of containment. We'll talk about rigid containment versus soft containment. And touch on how custom containment can provide the most complete option for your facility. We'll talk about managing airflow in a contained space, the differences between hot aisle containment and cold aisle containment. We'll talk about how containment works with your existing fire suppression system. We know a lot of you had questions about that in our previous webinars. We wanted to give you a little bit of more concrete knowledge as to how the two things work together. We'll be talking about monitoring the effectiveness of containment, because we all know you can't provide an RLE or an ROI, for something that you don't monitor. We'll talk about expectations for ROI that you can have with containment, and then we'll have plenty of time for questions at the end. Now, speaking of questions, we have brought you all into the webinar muted. We're going to field questions through our group chat on Zoom. So if you hit the chat button at the bottom, you can type your questions in there. If you'd prefer not to put them in the group chat, you can send your question directly to RLE and chat directly on there with me, and I'll make sure your questions get answered at the end. So with that, let's jump into containment.
Thank you, Jenny. You know, if you've been in the data center industry for really any amount of time, you're probably pretty familiar with containment, at least on some level. Containing aisles in data centers isn't new, and containment's been implemented and installed in data centers for years. So why would RLE feel the need to conduct a webinar on containment? Well, really the reason is we still see lots of customers, from small corporate data centers to large co-locations to multi-billion-dollar tech and telecommunication companies with hundreds of thousands of square feet of data center space that still haven't implemented any containment. So why is containment important? Well, we hope to answer that question for you as we move through this webinar. The image on this slide illustrates what tends to happen when cold and warm air in uncontained raised floor, when cold and warm air mix in an uncontained raised floor data center space. Cold air is supplied in an underfloor plenum and delivered through perforated panels and cold aisles, and warm air is returned to the cooling units to be reconditioned. Without containment, cold air can mix with warm air during the return to the cooling units, and warm air can recirculate into the cold aisles, increasing temperature of the cold air supply. In a properly contained space, cold air supply and warm air return remain separated, as you can see in the image here on this slide. This increases cooling efficiency. Ideally, cold air is only able to move through the servers, and warm air is returned to the cooling units. Without warm air and cold air mixing, it also becomes much easier to calculate the actual cooling for your IT loads. I'm going to hand it off to James now, who's going to talk about some of the cooling improvements and savings that can be gained through containment.
Thanks, Tim. So data centers are typically cooled to control the hottest spot in the room. This results in usually overcooling of the entire space to control just a few hot spots. So this image kind of shows a real-world example of a data center with no containment compared to a cold aisle containment. This CFD model on the left shows a data center without any aisle containment in place whatsoever. You can see that there are cold aisles with relatively warm supply of air and several hot spots. So this is mostly due to differences in server racks. Some may need more cooling, some may have a higher IT load than others. Mixing of hot air and cold air within the space only makes this worse by recirculating already warm air through the server rack, which makes the hot spot even worse. So in no aisle containment model, all 6 cooling units are on and supplying cold air to the underfloor plenum. The CFD image on the right, however, shows improvements after installing just cold aisle containment, including elimination of hot spots, which allowed an increase in cooling unit set points of 5 out of 6 cooling units, while still allowing an entire cooling unit to be placed in standby mode, thereby increasing cooling redundancy, efficiency, and overall capacity. When containment is applied to a data center, the return air tends to be warmer due to reduced mixing of air. If the return air temperature can be increased, cooling units become much more efficient. The chart at the top of the screen is kind of a good example of how much more or less a CRAC unit can actually provide based on return air temperature. The graph at the bottom of the screen shows a measured reduction in 30% of server fan speed and a reduction in overall cooling energy from 37 kilowatts to 33 kilowatts after cold aisle containment was installed in one data center. Now, we'll talk more about ROIs involving containment projects later on during this presentation, but most customers can easily expect to see a 20 to 30% savings in cooling energy after implementing aisle containment in their data centers. I'll hand it back to Tim now to talk about different types of containment.
Thanks, James. Really, when we talk about containment in data centers, there's 2 basic types. There's rigid and soft. This slide here shows examples of soft or curtain-style containment. And this type of containment is made up of strips of overlapping soft clear plastic that hangs from a frame or grid suspended above the aisle. It's generally less expensive than rigid containment, but usually doesn't look as aesthetically pleasing. It can also be less effective at containing a space. If an aisle is overpressurized or underpressurized compared to the surrounding space, the curtains can tend to blow open and let air mix in. And I've been in a number of data centers who have tried to implement curtain-style containment and seen the ends of aisles blowing around. Obviously, that lets air mix and defeats the purpose of installing containment in the first place. Rigid containment is usually made up of clear or translucent rigid plastic sheets in an aluminum frame. Rigid containment is typically more expensive, but looks much more aesthetically pleasing. It's also more durable over time, at least in our experience we found it to be. The aluminum frame that holds the plastic sheets is usually black or silver, but RLE can have it anodized to match just about any color. We talk about containment. If you look at the example on this slide, I mean, it would be pretty straightforward and easy to contain aisles if they all look like this. I mean, here racks are evenly aligned at the ends of the aisle. They're in a perfectly straight row, and all racks are the same height. But really, this is not typical of what we see in most data centers. Over time, plans change, rack heights and rack vendors change. Racks are added or removed to existing aisles, and some unique racks like storage racks don't usually match the height of server racks. The examples here are much more typical of at least some aisles we see in almost every data center we go into. Gaps within a row or uneven rows at the end of an aisle make it difficult to provide kind of a one-size-fits-all containment solution. In addition to uneven aisle lengths or gaps in rows, as we just kind of mentioned, rack height can often vary within a given row, and this is extremely common. We see this in every data center that we go into that's interested in containment solutions. Rooms can also have odd geometry. I mean, if every room was a perfect square or rectangle, it would be easy to make the ends of aisles all line up. But as you can see from the example in this slide, when you're trying to maximize floor space in a room with odd geometry, you can end up with some kind of odd aisle ends. So in this particular example, this made for some unique custom solutions to get those ends contained off. And finally, this is also pretty typical. You can often find an aisle without a corresponding row of racks. And for containment solutions, this requires that an entire side of the row be filled with containment. There are some standard non-custom solutions available on the market to contain aisles, but these solutions typically require that row ends be exactly even and really work best when rack heights are all the same. They also don't usually fully close off the top of an aisle completely, which lets some air escape out of the aisles. So for all the examples we've just reviewed, really custom containment solutions are required to provide the best and most complete containment of an aisle or row. When we talk to customers, one of the concerns that a lot of them have prior to installing containment is that if they install containment now, they won't be able to manage rack layout changes or expansion with growth. But really, in most cases, containment can be implemented with growth or plan changes taken into account. And here's an example of a system that was designed so that panels can be removed and replaced with racks as this row build-out continues. And really, this can be done for just about any configuration. The word custom shouldn't really scare anyone away from considering containment. The price of a custom containment solution is very competitive compared to available standard solutions. But as we'll see a little later on in this presentation, due to better efficiency gains, really custom containment can show some very impressive paybacks or return on investments. I'm going to hand it back off to James now, who's going to talk a little bit more about hot aisle versus cold aisle containment.
Thanks, Tim. So there's two main types of containment typically installed in data centers. There's cold aisle containment and hot aisle containment. As the name implies, cold aisle containment contains cold aisles, hot aisle containment contains the hot aisles. Beyond that, there's a couple more distinctions. Cold aisle is containing the cold air supply, which means the rest of the data center is at the hot air or the hot return air temperature. Typically, cold aisle containment contains the cool air from the floor to the top of the server racks, or in some cases with soft curtain containment all the way to the ceiling and at the ends of the aisles. Hot aisle containment, on the other hand, contains the warm server exhaust air in the hot aisle. When using hot aisle containment, the warm air is usually contained from the floor to the ceiling with vents in the ceiling to allow the warm air to be pulled into a return air plenum, and then that warm air gets sucked back into the cooling units for reconditioning. The cooling units are typically modified with a chimney on the top of them, which allows the warm air to be pulled directly into the cooling units from the return air plenum. Because of this, cold aisle containment is usually easier to implement in older legacy data centers due to the fact that it doesn't require a ceiling return air plenum. So here are some examples of soft and rigid hot aisle containment solutions. The image on the left shows a soft curtain hot aisle containment. Although hot aisle containment can be done as a retrofit to an existing space, we see it installed most often in data centers that are purpose-built for it. The image on the right also shows a hot aisle containment solution, but it's made using rigid panels. Doors on the ends of the aisles allow access to the backs of the server racks. While rigid containment can reduce leakage and lead to a more efficient cooling system, it's also more expensive. As mentioned with hot aisle containment, retrofitting a space to include a ceiling return air plenum can be costly and typically requires additional fire suppression systems for the ceiling plenum. In some cases, the hot aisle can be just one row of racks. We were recently approached by a customer utilizing high-density racks, some of them loaded to 21 kilowatts per rack. The racks exhausted the heat out the top of the rack, so a full aisle containment solution wasn't required. But hot air exhaust still needed to be contained on its way back to the cooling unit, simply because the return air temperatures were between 115 and 100 degrees Fahrenheit. The solution was just a simple chimney which added to the top of the racks, allowed for the hot air to escape from the rack into the ceiling return air plenum and all the way back to the cooling unit. This is just one example of how aisle containment can be flexible to suit the customer's needs. So here's an example about using chimneys with a CRAC unit. As mentioned, with hot aisle containment, CRAC units are typically fitted with a chimney to span the gap from the top of the cooling unit to the ceiling return air plenum. These are often made out of sheet metal, but they can also be made out of the same materials as rigid containment. This can often be a less expensive solution. Alternatively, even if you're not using hot aisle containment, chimney extensions on a cooling unit will still improve efficiency in your data center. This allows the cooling unit to take in warmer air as warm air rises through the cooling or the data center. This is very important in data centers with higher ceilings. It helps the cooling units to pull back the warmer air that rises all the way to the ceiling, rather than pulling in cool air that's already within the data center and trying to cool it even further. Cold aisle containment typically consists of doors on the ends of the aisles and either a containment ceiling directly over the racks or soft curtain style containment that extends from the tops of the server racks to the ceiling. The cold air should only be allowed to exit the space through the server racks. This allows the rest of the data center to become the hot air return. Cold aisle containment typically doesn't require a return air plenum in the ceiling, which significantly simplifies the installation and reduces cost. So which is more efficient? This question gets asked a lot, and while it may differ based on data center size, layout, capacity, generally speaking, hot aisle containment tends to be a better option. This is due to the fact that all the warm air is directed back to the CRAC units in the most efficient way possible, which increases the return air temperature and return efficiency of the CRAC units. However, implementation can be much more difficult, as stated before. If the data center wasn't purpose-built for hot aisle containment, retrofitting an existing space with a return air plenum in the ceiling is more expensive, and the extra efficiency gain over cold aisle containment may not be worth it. But again, this varies data center to data center. So this is a study on one data center using hot aisle containment versus cold aisle containment. This study was completed based on a data center 700 kilowatts in size, and the study was conducted over 1 year for both hot aisle containment and cold aisle containment. What the study found was that hot aisle containment generally leads to a 40% decrease in cooling cost over cold aisle containment, with no significant improvements in any other energy usage like server load. It's important to note that this was done in an ideal data center with perfect rows and a perfect layout. This is rarely the case in most data centers. In the end, the percentage of savings between hot aisle and cold aisle containment can vary based on the size and shape of your data center, along with many other aspects. In addition to this, you can see that as the uncontained area temperature increases, cold aisle containment actually gets more efficient due to a higher return air temperature to the CRAC units. Now I'll hand it back to Tim to talk about ROIs of the containment solutions.
Thanks, James. True return on investment or even simple payback on a containment project can be pretty hard to calculate accurately. Things like peak versus off-peak electric consumption, seasonal rates, and rate discounts offered to customers for reducing demand really all factor into the overall electric rate paid. And even when you can find that information, you still need to understand the actual baseline energy consumption of cooling units prior to project implementation so you can really determine the actual savings of making some proposed changes to the cooling unit set points, and possibly, if you've got enough redundant cooling, setting some units in standby mode. This really requires energy monitoring of the cooling units or chiller plant over time before any changes can be made. The examples on this page really show saving summaries of data centers where a detailed engineering study was conducted. These data centers were monitored for individual cooling unit and chiller plant baseline energy consumption, and then calculated savings was determined by the effects of our proposed changes, which in all three cases really came down to installing a custom cold aisle containment solution, which would then enable the customer to make significant cooling unit set point changes, and in one case, place redundant cooling units in hot standby. The calculations that we put together were very detailed. Each of these studies was done over a period of months, and the actual engineering study itself, they were between 50 to, I'd say, close to 100 pages. Our calculations were then reviewed and approved by either a third-party engineering firm or the utility companies themselves. But really the important point I want to make here is that in every case, the payback for the containment project was 2 years or less, and really this has been typical of what we see with most containment projects. Just to kind of review these again, every data center is unique, and that's why we're just kind of focusing on the summaries here. I don't think it's helpful to talk about exactly how many aisles or how many cooling units, et cetera, et cetera. Most legacy data centers that we work with will fall somewhere in the ranges that you see here. If we look at the top graph, really what's that showing is that by installing containment and proposing to make some set point changes to cooling units, and actually in this case they were so overcooled that after the containment was installed, we were able to use their control system to place cooling units in hot standby. We were able to show a savings of almost 738,000 kilowatt hours a year. This particular customer was paying 13 cents a kilowatt hour, so if you work that out, that's an annual savings of just under $96,000 a year. In this particular case, they were able to show a 1.4-year payback on the containment project. Looking at the second, or the middle graph there, again, completely different data center, completely different part of the country. They were not placing any cooling units in standby, but just by making some cooling unit set point changes after containment was installed, we're still able to show a savings of 603, almost 604,000 kilowatt hours a year. They were paying 9.8 cents a kilowatt hour, and that equates to just over a $59,000 a year savings. In that particular case, equals a 1.8-year payback. And the same for the bottom. This was a co-location company that we had worked with. This is a smaller data center, so the savings aren't quite as large. And they had done a lot of things right already, but they had not implemented any containment. And again, even with a fairly well-run, not too overcooled data center, we're able to show almost 500,000 kilowatt hours of savings a year. They were paying almost 11 cents a kilowatt hour, and we were able to show over a $53,000 a year savings. In this particular case, that worked out to right at a 2-year payback. So I'm going to hand it back off to James, and he's going to talk to us a little bit about managing airflow in a contained space.
Right. So, once an aisle is contained, it's important to know how to calculate how much cold air is required to cool that space. Ideally, enough air will be supplied to match or slightly exceed that IT load in that aisle. At a very high level, when we're looking at the entire room, basic rule of thumb for calculating cooling requirement is to take your available cooling tonnage and multiply it by 3.52. This will let you know how many kilowatts of IT load you should be able to safely cool. An example of this is if you have, say, 100 tons of cooling available, you should be able to cool approximately 352 kilowatts of IT load. Now, there's some caveats to this rule, such as making adjustments for altitude, restrictions within the cooling plenum, and that kind of thing. But this is a good starting point. Once you know you have enough cooling to satisfy the total IT load in the room, it's important to know how much of that cold air each aisle should get. Again, using a rule of thumb calculation can help ensure that enough air is being supplied to each aisle. For most rack-mounted equipment, 125 CFM per kilowatt of IT load can be used to calculate how much airflow is required for a given rack or row. Again, this is a rule of thumb calculation. We're not going to get into all the factors that affect actual determination of this presentation, like altitude, temperature differential, and supply air temperature. Once that number is calculated, however, you can look and see how many and what type of airflow panels are needed to satisfy that IT load. As you can see on the graph, CFM through an airflow panel increases with plenum pressure. You can use a chart like this to determine which panel and how many to use for a given row in your data center. More CFM at a server rack means more kilowatt of IT load that can be cooled. Now I'll hand it to Tom, who's going to talk about additional airflow measures and additional items you can do to prevent leakage.
Thank you, James. In addition to aisle containment, don't forget about the other areas that compromise airflow. Plugging holes is one of the easiest ways to improve airflow and efficiency in any raised floor environment. This becomes more critical when using aisle containment. If air escapes from the contained aisles through these types of openings, you are limiting the effectiveness of the containment and decreasing your cooling efficiency. The examples on this slide are cost-effective measures that are easy to implement in new or existing data centers. RLE foam grommets seal holes in raised floors, and with 50% less airflow loss than the leading grommet competitor, you know that you're getting an immediate efficiency return. In addition, RLE sells grommets individually, so you only have to buy the quantity you need. Every facility has those small spaces where airflow is an issue, whether it's cabling holes in the flooring from a previous facility configuration or narrow spaces between the flooring and the racks. Use RLE foam to fill these small spaces and gaps, in turn optimizing your airflow, your facility's airflow. We sell these in 24 by 24 by 2 sheets, which are pre-scored to 1-inch rows, so you can quickly separate out just enough to fill the pesky gaps in your infrastructure. In addition, blanking panels are a great way to prevent hot and cold aisle from mixing and ensure your cold air stays in front of the server cabinets where it belongs. RLE blanking panels are available in a variety of sizes and colors to suit the specifications of your application and are scalable, so you can adjust them as your application changes. Now I'm going to hand the presentation back to Tim to briefly talk about fire codes.
Thanks, Tom. When you're containing any space in a data center, it's always important to make sure that you keep local fire code regulations in mind. I want to make it very clear that we're not fire code experts here at RLE, and they vary from locality to locality. So always check with your local authorities to make sure that you're meeting your specific local fire codes. However, I will say that in supplying products and materials for Eastern data centers, we've learned quite a bit about fire code compliance. Typically, when you contain a space in a data center, you're really, in effect, creating another room or plenum. And should there ever be a fire event, the fire suppression systems need to be able to access this newly contained space. Obviously, one way to do this would be to outfit each contained space with its own fire suppression system, like adding a new sprinkler head, but that would become extremely expensive extremely quickly. And we have designs that help, with containment solutions, help work around those types of scenarios. In addition to making sure the contained spaces have access to fire suppression systems, the materials themselves often need to meet certain UL frame rating and or NFPA or National Fire Protection Association specifications. To address this, we've come up with some unique solutions, which I'll talk about here in the next few slides. one way to deal with making sure that your plenum is going to be open to fire suppression systems if an event should occur is to use drop-away ceiling panels. We recommend these a lot. These can be used in conjunction with soft containment solutions as well, not just rigid. And really, the drop-away ceiling panels are made from a lightweight or clear translucent plastic material that has a very specific shrinking point or melting point. Our panels happen to activate at 165 degrees Fahrenheit. And should there be a fire event and that temperature is reached, the panels will shrink and drop out of their aluminum frame and fall harmlessly to the floor. This opens up the contained space to the existing fire suppression systems in a data center room. Fusible links are also often used in our containment solutions with typically our soft containment options. A fusible link is made up of two pieces of metal that are linked together with a material that has a very specific melting point. In our projects, depending on customer needs, that activation point is either 135 or 165 degrees. But when the temperature reaches the activation point, basically the lower part of that fusible link will drop away from the top part. This allows the curtains to fall away from the ceiling, providing access by fire suppression systems to the previously contained area. Another option to use when using cold aisle containment are mechanical ceilings. A mechanical ceiling can be built to either raise up or drop down if there's an event, and these components link or are wired directly into the fire suppression system in your data center. So when the fire suppression system is activated, the ceiling panels automatically raise or drop to open the contained area. In the case of a false alarm or a test, the system can be easily reset, and it also uses the same drop-away panels as our standard ceiling, so redundancy is built into the system. If for some reason the mechanical part failed, those ceiling panels would still shrink at 165 degrees and drop out of the mechanical ceiling. So you can see with these types of solutions, we really have yet to be prevented from installing containment in a data center due to fire code restrictions so far anywhere in the country, even in cities with very strict fire codes like Chicago and New York City. I'm going to hand it back off to Tom now, who's going to discuss monitoring in a contained space.
Thank you, Tim. Once you've deployed a containment solution, the next step would be to monitor and fine-tune your environment to meet your energy efficiency goals, maintain optimal equipment performance, and ensure your facility is operating as you expected. So the RLE Wing Manager receives and aggregates signals from the wing sensors. This data is displayed on a web interface accessible from any browser or mobile device. Designed to keep the most relevant information close at hand, the web interface provides direct alarm notification, which allows users to quickly and effectively locate areas of concern. The Wing Manager will also send email alarm notifications and provide trending information to help pinpoint trouble spots in any monitored area. With wing sensors, you can measure temperature, humidity, differential air pressure, and air velocity. The sensors are compact and unobtrusive, yet provide an industry-leading battery life. Sensor batteries will last up to 12 years at room temperature. Wing sensors maintain this extended battery life while communicating readings to the Wing Manager web interface every 10 to 20 seconds. We knew it was important to our customers we didn't sacrifice data responsiveness in order to extend our battery life. The Wing system has unprecedented transmission range, up to 600 feet indoors, direct line of sight. While this range is more than ample for most situations, some applications require signals to be pushed even further, whether it's a complex physical environment or if there's RF noise. With the range extender, these distances can be increased up to additional 1,000 feet in the application. There are no licensing fees, and as the firmware evolves, you can update your wing manager to ensure your unit always has the newest features. Our open protocol approach streamlines communications and allows the wing manager to easily integrate into a larger BMS system via SMP, Modbus, or PACnet. In addition to wing sensors for monitoring, RLE also has integrated the wing sensors into our floor panels. The RFM panel, which stands for Raised Floor Monitoring Panel, is perfect for helping to maintain or monitor contained aisles. Ideal for differential air pressure and airflow monitoring and compatible with all RLE's suite of wing sensors, RFM panels keep reliable quality monitoring safely tucked into your raised floor system. Use these panels to understand static pressure loss or fluctuation, balance cooling airflow, and increase the available data points to understand the needs of your facilities. This panel can be used with any of RLE's wing sensors. Just drop in a panel and immediately gain transparency into your environment. RLE's containment experts will consult with you to design a solution for your environment. We will help design the system to maximize your efficiencies and energy savings. In addition, we can help you install the system or the containment solution. We also offer these services for the wing monitoring solution I mentioned before. So, in conclusion, I wanted to talk about the key takeaways from today's presentation. With containment, you can realize a reduction of energy usage of up to 30% and realize an ROI in 18 to 24 months. Soft containment is generally less expensive than rigid containment, but doesn't look as aesthetically pleasing, and it can also be less effective at containing a space. As mentioned, if an aisle is overpressured or underpressured, the curtains can blow open and let the cold air and hot air mix. Rigid containment is typically more expensive, but looks more aesthetically pleasing, and it's more durable over time. Generally speaking, hot aisle containment tends to be a slightly better option. This is due to the fact that all warm air is directed back to the CRAC units in the most efficient way possible, which increases return air temperature and return air efficiency of the CRAC units. However, implementation can be difficult if the data center was not purpose-built from the beginning for hot aisle containment. Retrofitting an existing space with a return air ceiling plenum can be expensive, and the extra energy efficiency gain versus a cold aisle containment system might not be worth the additional expense. Custom containment will deliver the best fit and efficiency gains, and as we saw in previous examples, sometimes custom is just mandated by the design of the data center. Once you've implemented containment, don't forget the additional airflow measures and plug the holes with grommets, foam, and blanking panels. Finally, once you've deployed a containment solution and implemented the additional airflow measures, don't forget monitoring. With the RLE wing monitoring solution, you can fine-tune your environment to meet your energy goals, maintain optimal equipment performance, and ensure your facility is operating as you expected. Now I'd like to return it to Jenny and open up the call to the questions.
Thanks so much. We do have a couple questions that came in through private chat. If anybody has any other questions, you can go ahead and pop them into the group chat, and we'll make sure we address them. So the first question I have is, you said in the presentation that your grommets have 50% less airflow loss than the competition. How do you know this?
I'll take this question. So our grommets use a soft foam for them. We've compared them to competitors using a raised floor, kind of like a test fixture for raised floor, so we can provide the plenum with 0.05 inches of water pressure, so like a normal data center. And compared to our competitors, we've actually seen a reduction of 50% of air leakage through the air grommet. And again, that's because we went with a much softer foam that allows for it to seal around the cables a lot better. Yeah.
Thanks, James. We have another grommet question. I've seen the round grommet on your site. Does RLE offer square grommets too?
We're actually in the process of developing our next set of grommets. Jenny, these will be available by the end of this year and will include common square and rectangular sizes.
Thanks, Tim. Okay, here's our next question. What is the ASHRAE recommendation for sensor placement if I'm monitoring my rows and cabinets?
Well, there's no real directions or there's no real one-size-fits-all for like sensor placement or anything in a data center. It's really going to depend on what you're trying to monitor and what your data center looks like. Yeah.
Jenny, we have customers that, you know, I've worked with customers who want kind of one temperature sensor, temperature humidity sensor on every third cabinet, and I've worked with customers who want 3 sensors per cabinet, one at the bottom, one in the middle, and one at the top. I don't think, as James mentioned, I don't know that there's necessarily an ASHRAE specification for that, but if there is, it's not followed regularly. Customers basically look at their IT load, their problem areas. If you're a co-location customer, you're going to have an SLA that you're trying, or a service level agreement that you're trying to meet. So it really depends on the need of an individual customer and what they're trying to achieve through monitoring. I would say most of our customers are putting 1 sensor per rack, and they're usually placing it at the highest level of equipment in that rack. So if your server, the highest server is at 4.5 feet, that's typically where we see a sensor being placed. If it's all the way at the top, they'll place the sensor all the way at the top. Obviously, the goal is to try and ensure that you maintain a safe operating temperature for the equipment in that particular rack.
Thank you, guys. Next question also looks at monitoring. What are the common applications for the RFM panel?
I would say the one we see most is to measure differential pressure between the floor plenum and your raised floor and the open space in the data center. It's pretty convenient. You can just pop it in. It's wireless. So once you have the sensor mounted in the floor panel, it's very easy to move that floor panel from location to location. If you want to check how your pressure varies across a data center, it's also a good idea to have one, at least one, in a contained space to make sure that you're not under pressurizing that space. If you were to have a contained aisle that for some reason was under pressurized, basically you're letting outside air back into that space, which you don't want to do.
Thanks, Tim. And it looks like I have one more question queued up here. Can you tell me how long it would take to get custom containment in my data center? Since it's custom, does it have a long lead time?
No, not generally. I mean, I guess it depends on your definition of long, but typically we can have a, from the time of order, we can have materials shipped within 3-4 weeks at the most. And usually, depending on the size of the data center, most installations can be completed within a week. Now, if you've got a huge data center, and we're talking, 50,000 square feet or more, and none of it's contained, and you'd like us to come in and do it, obviously that's going to take a little bit longer. But most materials can be delivered within 4 weeks, and most of our installations don't last more than a week.
Excellent. That is the last question that I had submitted. If anybody else has anything, we're happy to chat longer. We are at a little more time, but if not, I wanted to thank you all for attending today. Tom Metzinger's contact information is on this last slide here that you see. You are welcome to reach out to us anytime. We're always happy to answer any of the questions you have about monitoring or containment, We're happy to have a chat about your facility and what your maybe what you're struggling with, what some of the issues you'd like to help clear up. We are happy to just have a chat and propose some options to you. So reach out to us anytime. Other than that, thank you all so much for attending today. We hope you have a safe and healthy day, and we really appreciate you spending the morning with us. Thank you.